right, this is Unit 12, Lesson 11, Part 2. We're going to be doing something called Proving Identities, and this is going to come back using those same identities that we had in Part 1 of this lesson, except we're going to use them to prove identities. And proving identities means you're going to prove that the left-hand side and the right-hand side are equal. All right, so we're going to do the odds. So the way that we're going to work this is our technique here. You want to simplify one side, usually. Like sometimes you'll run into a situation where you have to simplify both sides a little bit, but for the most part, you're going to simplify one side until it matches the other side. And the technique you usually want to take is that you'll start with the more complicated side. All right, so we're going to do the odds on these two pages. So starting with this left-hand side, we want the left-hand side to equal the right-hand side. Visually, it looks like this left-hand side is more complicated. So we start with that left-hand side, transform it as much as we possibly can until it matches the right-hand side. All right, once we get that left-hand side to equal sign, we are done. We have proven that the identity is true. All right, so tangent. Tangent, remember, is sine over cosine, divided by secant, and remember secant is the reciprocal of cosine, so we can write that as 1 over cosine. Okay, so at this stage, we are just hoping that it is equal to sine, which is what we have on the right. Back to the left, we have a fraction divided by a fraction, so we can flip and multiply by the reciprocal. So we have sine over cosine, and then we are going to multiply by the reciprocal. So 1 over cosine becomes cosine over 1. And again, we are hoping that that is equal to sine. Look back on this left-hand side. We have a cosine in the numerator, canceling with a cosine in the denominator. That left-hand side is now just a sine, which does, in fact, equal sine. So this, your last line, is two identical sides. That's how you know you're done. I like to end mine with a little like, check, we did it. That's how you know you're done, is when the two sides are the same. All right, so that's what it means to prove an identity. Let's look at number 3. Number 3, the right-hand side appears visually to be a little bit more complicated than the other side. So I am just going to keep my left-hand side the way it is. We want to see if it equals that right-hand side. Cotangent, so you can either think of cotangent as the reciprocal of tangent, but it's usually better to get things in terms of sine or cosine if we can. So cotangent is cosine over sine, divided by secant, which is 1 over cosine. And then we are adding sine to that. We want to see if those two things are the same. So this piece right here, this is the same as multiplying by the reciprocal for dividing fractions like that. So these fractions, we have cosine over sine multiplied by cosine over 1, and then we are adding sine to that. Okay, so these two things get multiplied together. So left-hand side, I'm not doing anything. These two things get multiplied together. I get cosine squared in my numerator over sine. And then I'm adding sine on this piece right here. So this is something that's going to pop up a lot when you're proving identities. If you have addition like this, you are going to have to get a common denominator so that you can add them together. All right, so multiply top and bottom by sine over sine so that you can match this. So when you multiply the numerator by sine, sine times sine becomes sine squared, and then you multiply the denominator by sine. All right, so we are going to just extend this. We're not doing the even, so I'm going to extend this over onto the right. So the numerator, I have cosine squared plus sine squared over this common denominator of sine. I'm going to keep it going. This, if you remember back from part 1 of the lesson, when you have cosine squared plus sine squared, that is equal to 1. So if that ever pops up perfectly, just replace it with a 1. So now we have 1 over sine, and now we are getting somewhere. On the left-hand side, we have cosecant, and then this is 1 over sine. So remember, those are reciprocals. The left-hand side is cosecant, and that's actually exactly what we had here. 1 over sine is, in fact, equal to cosecant. Once you get the two sides to match, then you are done. All right, number 5. We have a cosine squared on the left. We have what's definitely the more complicated option on the right. So I'm, rather than like doing this many, many times over, I'm just going to work with the right-hand side until it equals cosine squared. And then that's how we know we are done. So cosecant is the reciprocal of sine times cosine, which is already cosine, so I'm just going to leave that, over tangent. So tangent is sine over cosine, plus cotangent, which is cosine over sine. Okay, so lots of simplifying that we can do here. So numerator, you can think of this just as like cosine over 1. So the numerator is just cosine over sine. If I take these and just multiply them together. Over, and then in the denominator, just like I talked about up here, whenever you do addition, you have to have the same denominator. So this one needs a sine to match this one. This one needs a cosine to match this one. So I can multiply this one by sine over sine, and I can multiply this one by cosine over cosine. Okay, so now they both have a sine and a cosine, which means the denominators match. All right, so this one, sine times sine would be sine squared, plus cosine times cosine would be cosine squared, over my new common denominator of sine times cosine. Okay, so we are getting there. Everything is combined up. One other thing I want to look at, you see this? We did the exact same thing right here. When you have cosine squared plus sine squared, which is the same as sine squared plus cosine squared, you know that's equal to 1. So let me rewrite that. So numerator, we have cosine over sine, over, and then this is just 1 over sine times cosine. Okay, so now we have a fraction divided by a fraction, which means I'm going to flip and multiply by the reciprocal. So times, we flip this to sine times cosine over 1. And if you're looking for some canceling, we have sine in the numerator, sine in the denominator. All I have left is a cosine times a cosine, which is a cosine squared. And that is what I started with on the left-hand side here. So that is equal to the left-hand side. All right, let's look on the second page. I'm going to keep on going with these odds. So I've got 3 down, 3 to go. I'm going to look at number 7. So number 7, we actually did exactly this when we were simplifying the identities in part 1. All right, so this, if you're looking at the left-hand side versus the right-hand side, neither one of them are all that complicated, or you can consider them to both be averagely complicated, I guess. I'm going to say start with the left-hand side, because the right-hand side only has one trig function. The left-hand side has 2 different trig functions. So we're going to take this cosine squared, and this should look familiar from part 1 of your notes. Remember, if you have this guy, this is our main Pythagorean identity, which we'll be working with more and more. We rewrote that. We solved for cosine squared by subtracting this sine squared over to the other side. So this is 1 minus sine squared. So left-hand side, we are taking that cosine squared and we're replacing it with 1 minus sine squared. And then after that, you still have minus sine squared. Okay, so I have this, they match, which means I have 2 of them. So I have 1 minus 2 times sine squared of theta, which in part 1 of the notes, all we are doing is simplifying. In this part of the notes, we're matching, and this left-hand side now looks exactly like the right-hand side, and that's how we know we're done. All right, number 9. Left-hand side, we have secant squared. Right-hand side, we have what seems like it could be very easy. People like to look at these and think that they can just cancel those, and you cannot. The denominator is part of a binomial. The numerator is not, so you can't reduce binomials. I would start with that right-hand side. I think it looks just a little bit more complicated. So right-hand side, we're going to come back to some of our Pythagorean identities here. So if you look at cosecant squared, okay, so cosecant squared, if I take this one, just rearrange it a little bit. If I subtract 1 over here, then I could say that cotangent squared is equal to cosecant squared minus 1. And that is exactly what I have here. Okay, so I'm going to take that right-hand side. I'm replacing the denominator with cotangent squared. All right, which seems like it might be making things just a little bit more complicated, but I want to get things in terms of sine and cosine now. Okay, so sine and cosine. Cosecant is the reciprocal of sine, so 1 over sine squared over, and cotangent is cosine over sine. So since it's squared, it's cosine squared over sine squared. All right, so fraction of fractions. I take this one and I multiply by the reciprocal of this one. So multiply by the reciprocal of this one. Sine squared becomes the numerator. Cosine squared becomes the denominator. We've seen this happen a lot. We've got this canceling happening top and bottom, which equals 1 over cosine squared. So this is the reciprocal of cosine, and the reciprocal of cosine is secant. So since this one is squared, this one is squared, and now my right-hand side matches my left-hand side, and I am done. There's really nothing to box up with these. You might have noticed that. You just work and work until the two sides match. All right, one last one, number 11. I would say the left-hand side is definitely more complicated. You just need all of this to equal this. Start by getting things in terms of sine and cosine completely. So I have cosine theta, which already is, plus sine times, now tangent is sine over cosine. Okay, so that's my left-hand side. Starting to work with that left-hand side, we're gonna work and work until it equals secant. So this, think of this as like sine over 1. So multiplication comes before addition. Multiply all this out. I get sine squared over cosine. Now I have two pieces that I need to add together. If you want to add two pieces together, they have to have a common denominator. So this one, think of this as like cosine over 1. This guy needs to have a denominator of cosine. So that means I am going to multiply top and bottom by cosine. So multiply these two together. Cosine times cosine would be cosine squared plus sine squared right here over my common denominator of cosine. Again, very tempting to try to reduce or cancel these. You cannot, because this is part of a binomial. But you might recognize our Pythagorean identity. I wrote it up at the top here. Cosine squared plus sine squared is equal to 1. So anytime you see this, you can just replace it with a 1. That's not the first time we've done this. So 1 in the numerator over a cosine in the denominator. And this is the reciprocal of cosine, very similar to what we did here, but this is just one copy. So 1 over cosine is just equal to secant, and secant is what we started with on the right-hand side. So that means that we are done.